Welcome to understanding RDBMS with examples. After watching this video, you will be able to describe what RDBMS is, explain fundamental concepts such as primary keys, foreign keys, schemas, and indexes, describe how RDBMS organizes data through relationships, and explain where and how RDBMS is applied in the real world. In this video, we'll explore the foundation of modern data management, which is the Relational Database Management System, or RDBMS. Let's start with the basics. RDBMS is a type of database system that organizes data into tables. Each table consists of rows and columns. Think of a table as a grid. Rows represent individual records, and columns represent fields or attributes. For example, a table that stores student information might look something like the one displayed here. This kind of structure makes it easy to retrieve, organize, and analyze data. To make tables useful, relational databases rely on two types of keys to uniquely identify records and establish relationships between tables. First is a primary key, which is a column or a set of columns in a table that uniquely identifies each record. For example, the student ID column in the previous table can serve as the primary key because every student has a unique ID. Primary keys ensure there are no duplicate records in a table. The second key type is a foreign key, which is a column in one table that references the primary key of another table, creating a relationship between the two tables. For example, let's say you have another table for course enrollments. Here, the student ID column in the enrollments table acts as a foreign key, linking each enrollment to a specific student in the students table we saw previously. This relationship allows you to see which students are enrolled in which courses without duplicating student information in every table. An important concept in relational databases is the schema. A schema is like the blueprint or structure of the database. It defines the tables in the databases, the columns in each table, including their data types, the relationships between tables, and constraints like primary keys and foreign keys and validation rules. Good database design starts with creating a schema that organizes data effectively. One principle of good design is normalization. Normalization is the process of breaking data into smaller, logically related tables to reduce redundancy and improve data integrity. For example, instead of storing the same course name multiple times in an enrollments table, we might create a separate courses table as displayed here. Then, we would reference the course by its course ID in the enrollments table, making the database more efficient and easier to maintain. Another critical concept in RDBMS is indexes. An index is a database feature that speeds up data retrieval. Think of an index like the index in a book. It helps you quickly find the page you're looking for instead of flipping through every page. For example, imagine a table with thousands of student records. If you frequently query the table to find students by their student ID, creating an index on the student ID column would significantly improve query performance. Without an index, the database would have to scan every row to find the matching record, a process known as a full table scan. Indexes are especially helpful for large databases with millions of records. However, they do have a trade-off. While they speed up queries, they can slightly slow down insert and update operations because the index also needs to be updated. Now that we've covered keys, schemas, and indexes, let's dive into relationships, the backbone of relational databases. Relationships define how data in different tables is connected, and there are three main types. In one-to-one relationships, each record in one table is linked to exactly one record in another. For example, a person table might have a one-to-one relationship with a passports table. Each person has one unique passport, and each passport is linked to one person. In one-to-many relationships, a single record in one table is associated with multiple records in another. For example, a customer table might have a one-to-many relationship with an orders table. One customer can place many orders, but each order belongs to one customer. In many-to-many relationships, multiple records in one table are associated with multiple records in another. For example, a student's table might have a many-to-many relationship with a courses table in a school database. A student can enroll in multiple courses, and each course can have multiple students. This type of relationship is usually implemented using a join table, like enrollments. Relational databases are used across almost every industry. Here are just a few examples. In the e-commerce industry, they can store customer data, product catalogs, and order histories, allowing for features like personalized recommendations. In the healthcare sector, they can manage patient records, appointment schedules, and billing information while ensuring data integrity and privacy. In the banking industry, they might track customer accounts, transactions, and loan records, where data accuracy is critical. Relational databases are ideal for structured data and scenarios where relationships between data are essential. However, NoSQL databases might be a better fit for unstructured data or rapidly changing data. For example, NoSQL databases like MongoDB excel at handling large amounts of real-time data, but they lack the rigid structure and relationships that make RDBMS powerful for many business applications. In this video, you learned that RDBMS databases organize data into structured tables. A primary key is a column or set of columns in a table that uniquely identifies each record. A foreign key is a column in one table that references the primary key of another table. An index is a database feature that speeds up data retrieval. Database relationships define how data in different tables is connected. And the three main relationship types are one-to-one, one-to-many, and many-to-many, and RDBMS databases play a vital role in industries like e-commerce, healthcare, and banking, making them a cornerstone of modern applications.